This is a continuation of the previous video on section 3.2, and it's going to further explore measures of center. In certain problems, we won't be given the actual data set, and instead we'll just be given the frequency distribution. So in other words, here we have a frequency distribution. We know that there's 28 values in between 21 and 30, but we don't know what those values actually are. If we wanted to find a mean of this distribution, we need to have something to represent those 28 values, and we're going to use the class midpoint for all 28. So the midpoint of 21 to 30 is 25.5. So we count this as the value for all 28 of the data elements in that first class. Okay, we count 35.5 for all 30 that are in the next class, etc., etc. So for the mean of a frequency distribution, we're using this equation right here. Okay, x is the midpoint. That gets multiplied by however many there are, so 28 times 25.5 for this first one. Okay, we do the same thing for each one of these classes, multiply the midpoint by how many there are. Okay, and in the end, we're going to divide by the total sum of the frequencies. Okay, or in other words, how many data elements we have in our data set. So let's go ahead and do this example and find the mean age for best actresses, which is the same data set we used in the previous chapter. So first step is take each frequency and multiply it by the midpoint. That's going to go in each of these boxes over here. Okay, when we do that, we add them all up. That's at the bottom here. We see that there's a sum of 2,718. Now to find the mean, first off, this we would use the variable mu because this is the population of all winners of Best Actresses, at least when the book was written. Okay, it's the sum, which is this last column here. So 2,718 divided by the total frequency. How many winners did we have in total? 76. Okay, gives us a mean of 35.8 years. Now, if we compare this to the actual data set, if we had the actual ages of all these winners, which we did in the previous chapter, we would find that the actual mean is 35.7. So this is a pretty accurate way to find the mean based on a frequency distribution. Now, there's something really similar called a weighted mean. If we look at this, this is really the same equation, except we've changed the f's to w's. This was an f, this was an f. Otherwise, this was the same exact equation. We would use a weighted mean to find things like your average in a class, where tests are 20%, quizzes are 30%, quarterlies 25%, etc. Okay, you would have a test average that gets multiplied by whatever weight that has of 30%, multiply your quiz average by that weight, etc. For example, let's say one of your classes, you've had 3 tests in, you want to find your test average, but we can't just add the 3 scores together and divide by 3 because they're weighted differently. Maybe they were different lengths. The first one was short. That counted as 20% of your test grade. You got an 85 on that one. The next one was a bit longer, so that one counted as 30% of your grade. You scored a 90 on it. And the last one was the longest test, so that's 50% of your grade, and you scored a 75% on that one. Okay, so we would arrange this in the same way we did with the frequency table. This is the equivalent of the midpoints, which we had labeled as x, and each of these has its own grade. So our first step is just to multiply across those columns and get their weighted average. Okay, so that gives us these numbers here. We total all of them up to get 8150 and then divide by the frequency. Frequency is what these numbers total to. Okay, if you wanted to use these as actual percentages and make them 0.2, 0.3, 0.5, that's okay. It's just that they would total to 1 instead of 100. So for our actual average, we have the mean test grade. It's a population because it's all 3 of your test grades. Added up, they equal 8150. Divide by 100, mean test grade of 81.5. Lastly, when we're evaluating the center of a distribution, knowing what the shape is can tell us a bit about what that center is. For example, if we have a symmetric distribution, it's unimodal, it's bell-shaped, the mean, the median, and the mode are all approximately the same value, and they're right at the peak of that symmetric curve there. If we have a distribution that's skewed to the left or negatively skewed, here we have a tail on the left side. Okay, there's longer, more spread out values on the left, and all these measures of center are going to shift a bit. So the mode is at the peak. Okay, the mean is pulled farthest to the left. Okay, the mean is always pulled more away from the center than the median is. The median stays in the middle of the mean and the mode. For a distribution that's skewed to the right or positively skewed, it's really just the reverse. So here we have this tail on the right side. The mode is still at this peak. Okay, the mean gets pulled towards that tail, and the median stays in the middle of the mode and the mean.